Hello dear students, welcome to the lecture 14 of Object-Oriented Programming with C# course. So today we will continue from our previous lecture, which we were developing a multi-threaded web crawler. I will copy and paste its code to continue and make changes, so you will have both of them as a separate directory. Okay, and it says it is open somewhere else. This is weird. Okay, now it is done. Let's open it. Okay, if you remember from our previous lecture video, we had hard time to set default values, and I think we can solve it easily with inheritance. So today I will start with that and then continue. You see, developing a good software takes a lot of time and thinking and planning. Okay, it is not just that you write the code in a single coding session and then it is done. Not like that. Okay, so to fix it, I will change our custom crawling result class. So the crawling result class will inherit actually our entity framework class, which were automatically generated, as you can see here. So this will be inheriting our entity framework generated class, and even if we do update entity framework generated class, it will remain same. Okay, so we have crawl success, and you see we don't have it in here, therefore this can remain same. So crawled URL, and do we have crawled URL here? Yes, we have, therefore we won't be having this anymore. And discover date, do we have discover date? Yes, we will delete it. And linked depth level here, delete it. And last crawling date is here. Okay, so we can set its default value on our inheriting class. I will make it as like this, and I think we don't even need to use this. Okay, and it is public. Yeah, it should be working, but why I am not able to? Oh, I know the reason. The reason is simple, because I can only change its default value in the constructor of the crawling result class, and let's change it and make the assignment here. Okay, now it is working, because here we are defining the variable or the property. We cannot set it without defining it. If we want to set the inherited class properties or fields, we have to use a constructor like here. So this is the default constructor, by the way. Okay, crawling time ms, and we don't have, I think we have it here, fetch time ms, so I can remove it. And crawl source code, I think we have the crawled source code as well, so remove it as well. And crawled URL hash, we have it here. Discovered links, which is not available here, so I will keep it. Title of a page, we have it here, remove it. You see we are reducing our duplicate code, and we are fully utilizing the inheritance mechanism. This is actually what is being about object-oriented programming. Okay, this is how you should program your software, and parent URL hash, we have it as well. Okay. So even if we update our inherited class, this, I mean the parent class, which is being the main TBL mean URL, which is automatically generated by the entity framework, our inheriting class will not get affected. Okay, it will include all the new features of the updated TBL main URL class and also our additions and the default values if we want to set. Which values we want to have default values? Last crawling date, and then whatever the date we want. Okay, we will set it as we continue. So since we have removed the older ones, we will change these ones as URL. Parent URL hash will be URL hash. Okay, discover date will be discover date. You see, these were getting from the crawl page. Okay, and okay, crowded URL will be URL, and crowded source code will be source code like this. Crowded time ms will be fetch time ms. Okay, let's change it as well. And title of page will be page title. Okay, what else? Okay, crowded URL will be URL, and okay, discover date, fetch time ms. Oh, by the way, I don't need to do this anymore because here we were generating a TBL main URL instance, and instead of that, I will simply use the crowded result. Okay, so I don't need to make any of these here. And okay, I only need to do, let's see, I will delete this, and the URL hash will be like this. Okay, this is correct, and here, okay, and here, all right. So you see, I am able to add TBL main URLs the crowded result, even though the crowded result is from crawling result class, because the crawling result class is a child class of TBL main URL. Therefore, it allows me to add an instance of crawling result to do TBL main URLs, because the TBL main URLs is the parent of crowded result, which is the crawling result class. Okay. And I don't even need this. Okay. And all right. So we don't need to change this. We don't need to change this. We don't need to change this. You see how much duplicate code we are removing with inheritance, and the parent URL will be like this, and the source code will be like this, and comparison. Okay, can we use comparison? Okay, we have to set the comparison. Okay, to be able to see the comparison percent, we have to keep the original string length. So let's set it somewhere here. Okay, original source code length equal to, okay, source code dot length. Normally this is integer, however inherently it will convert it to double. All right, and then I can use I could also use the to double method, but it is not necessary. It will inherently convert it. Okay, source code, which is here, original source code length, it is double, and the crowded results, okay, source code length to double. I am converting it to double here to make this appropriately converted to percent. Okay, so we have the URL as well, and then we have the save changes. All right, and okay, everything is looking good. Let's test our application. So first put a breakpoint here and then a breakpoint here. Okay. All right, so let's also open our database. I will try both update and a new URL instance. Okay, I will start with testing my one of my projects, web-based game. Okay, this is the URL of it. Okay, we can change the language to English if you want to read it. Application is getting opened. Okay. So this URL does not exist in our database currently. Oh, okay. It's taking time, so I'm just closing it. Unfortunately, my laptop is a bit slow, so it is taking a lot of time to just open it, and probably Windows is also installing some updates at the background. Okay, all right, and let's open our database, main URLs table. Okay, you see it is not here, so let's start crawling, start initial crawling. Okay, URL to crawl, and we have assigned it to local URL, and then we compose an instance of our crawling result class, which is a child class of TBL main URL, and we assign our local URL, and as a parent URL we assign it, because this is the root URL actually right now. Discover date will be the discover date it is getting from our crawl page button. Click and we start our stopwatch. We download the source code. It is downloading. Okay, source code is set like this. Okay, it is looking fine. Let's continue. And we stop our timer. By the way, the timer will of course have incorrect timing because we are doing a debug right now. And okay, we have converted the elapsed milliseconds to the integer, which is by default, I don't know, we need to check. And the crawling result is success. Therefore, I compose per document result, and I add the discovered links. So these are the links that are discovered, and if you see something is not correct, you can remove it. By the way, you see there are also external links right now. So we are also at the moment discovering the external links. You may want in your project, it should be optional, so you should be able to set discover external links or do not discover external links, which you can achieve it with checking the domain of the extracted link. And we set the page title, okay, and save crawling is in database, so this is the our saving method. So crawling success true, and we open the crawling session with using context from db crawling class, which is entity framework class, automatically generated. Okay, we calculate the hash of the URL after normalizing it. All right, and we get the we check the database whether there is record exists or not, and you see it does not exist. So this is checking the hash of the normalized URL and whether it exists in the database or not. Then it adds it to the context for keeping tracking changes. Okay, so mapping and metadata information could not be found for entity type. So our inherited class having a mapping and metadata information. So let's see another problem to solve. Okay. This is not the okay. How to insert derived class? Yes, this is the correct thing that I want. Table per hierarchy. Okay, there is person and user class which is inheriting from person, and person is the entity class. Okay, let's look for the error. So derived class and the error message we are typing, and someone has already asked it that on the Stack Overflow 7 years ago. Let's see why we are not able to add it to the context. Okay, the values are there, but when we add it to the context, we are having a problem. Let's see the error message. Okay, view details message is this one. Stack trace. Okay, so I have added property to the entity without updating Poco class. What is Poco class? Properties, entity model generator, entities. Still nothing answers our question. Okay, so this is entity, we have extended like this. Okay, yes, this is exactly our problem. Oh, I see. So we need to edit s with s command. Okay, so it doesn't inherently converting it, so it will be as like this. Okay, let's continue and test it again. So I will remove breakpoints and put a breakpoint here. Okay, I would expect it to inherently do that, but it didn't work. Okay, let's continue, and here, okay, we still have a problem. Context food and the end. Because it looks like it is not the correct answer. Please on convert this object product model. I see. So they have used serialization to convert inherited class into a new class. I see. Okay, I think we can test it. So, what we can do is we can do something like this. We set the values here, then we compose an easy conversation. But before doing that, let's check it. So there is no easy answer. Okay. Okay, I think I will go with this one. So here what we are going to do is we will compose TBL main URL final object, and it will use JSON convert. However, for JSON convert we need to install package Newtonsoft JSON, and I think we have already seen that in the previous lectures, how it can be used to save state of an object, and in here we will use it to convert our object, which is crowded URL, to its base URL, I mean base class, and then we will edit or attach it. Okay, so let's check this out. I am hoping that this will work. So basically we are doing a conversion from derived class to base class, okay, parent class, because it appears that Entity Framework is not supporting derived class. Okay, it appears that we have a problem somewhere here. So we have called the normalized URL here. And why did it give error? So let's try again. Interesting. Start initial crawling. Okay, URL hash. The URL hash is there. And we get the result. Okay, result is null. Problem parent URL hash. Oh, why there is parent URL? And did we miss something somewhere? I know the reason. It is because you see there is parent URL, and you see we have assigned it to URL hash. This is a mismatch done by us. So this will be parent URL hash. Okay. And then we will take hash of it. Okay. Okay, and okay, let's continue. Okay. Okay, original source code length is 100k length, and then it becomes compressed to 29,000, and the compression percent. Okay, so original content length. Yeah, we have mistyped the order. It will be like this. Okay, let's run it again. Okay, we have reached this point. Let's see. Yes, the conversation is done. Okay, let's see the mapping. Okay, the mapping is done perfectly fine. You see from crowded result class instance, we have converted it to base class instance. So you see base class instance does not have the extra properties which are BL crowd success and the list of discovered links. Then we can add it to our context and we can save changes, and let's continue to check our database. Okay, it is saved. Nice. It is saved perfectly fine. And let's try to update. Okay, and this time I will just execute it. So it should update as before. Oh, okay, we have attaching an anti-type object because anti-type. Okay, so it says that it is already there, therefore you can't attach it. Okay, why? Because it is already attached, I think. I think we should be able to check. Contains final object equal to false. Yes, we can then attach it. Then we can change the modified state. This should work. Okay, so let's try this time with a new URL. And then we will try with existing URL as well. Okay, this is a new URL. Okay, edit to the database. Yes. Okay, last crawl date is here. Then let's try to update. This time it should update. Okay. I see. I can do try and catch. However, I am looking for a better option. Okay, is attached to. Let's see if there is. Is the attached. Get object ID. Okay, so it checks the key. Okay, so what we need to do here is enter the key and enter the state. Okay, this is not the way I think that solves our problem. Yeah, I think this is a better one. So the context is here, entity var AAID my entity. So our ID is the URL hash. Therefore, I need to check URL hash, and it is checking whether there is any. If there isn't any, and if this is false, we will attach it. If not, we will just continue. Okay, this should work. Okay, let's try it again. I could simply use try and catch but to catch the error. However, that is not what I want. I want to properly handle the exception. So this is initial adding a new URL. Okay, it is added. Then let's try update. Okay. But we didn't attach it. Why? It says already on the you see we have made a programming error and it wasn't rebuilt therefore, so it will be now ineffective. Let's delete the links. Okay, I have deleted the older ones. It is empty right now. Okay, it is here, and let's try again. Okay, this is really weird. Why? Oh, it says the state of entity changed or modified. Okay, so how will I set its entity state? Maybe we don't even need this. Okay, so I will make it like something like this. Let's try. We can't know until we try it. Okay, and let's okay, so it should be updated. Discover date is 20 and I will execute it here to comparison. Oh, it appears that it is not updated. Or maybe updating, let's see. No, not updating. I will take a pause for a moment. Okay, I think we can first remove the instance and then we can reattach it, but we need to be sure that it doesn't make any database insert, update, or delete. Okay, so I think we can use detach, and how can we do it? Let's see. So we will do first deattach and no, this is not we want. When we do make this, okay, I think we can make it like this. Okay, so here I will make a test and see whether it makes any database request or not. Probably it doesn't make because we are not saving changes yet. And we need to also remove this if clause. Okay. I'm not sure if this will work or not. For example, let's try this URL. It is fine. So at the initial crawling, it will just add it to the database. Okay, it is here, and when we do the update, yes, it will get detached. Okay, then okay, it says because it didn't detach. How can we change the attached entity state to modified? Hmm. Attached entity. Hmm. Okay, let's see. Here our thing is attached, but it doesn't save the changes. How do we change? I think I have an idea. Hmm. Okay, what we need to do is something like this. Hmm. I think if it is true, we will set it. I mean, can we set it something like this? I'm not sure. Yeah, probably only way is detaching and then attaching. Hmm. I think I will something like make something like this. Okay, first I will detach and then I will make a save. I think it will execute database query. However, I don't know how else we can make an update. Because it can't simply know which values are updated because we are using a new instance of the crowded URL. Basically, it is equal to updating every parameters of an existing object. So let's open the profiler to see. Okay, connect. Okay, and when I execute this line, let's see what happens. Okay, it didn't do anything. Nice. And then it is still not attaching. There is remove. Let's see. Maybe remove will work. Okay. Let's first try like this and then I will try with context save changes as well. Okay, this checks that it exists in the database. I see. So I have to check object state manager. Okay, let's try this method extension. You don't need to reinvent the wheel. Okay, public static void attach or to get t this object context. So it says okay, string entity set name, entity I entity with key. Okay, and how does it work? Okay, I attach or get users ref user. This is not what we want. We have to first remove it or set its state to delete it. Maybe this is a better way. Let's remove this because this is not what we want. Okay. Delete it, save, and then run. I think alternatively you can do something else. Yes, I have an idea. Yeah, I have an idea. So let's first compose this object, then okay, we assign it to something like this. Okay, and so we will get first or default. All right, so this will get the reference of that context. Then we can convert it to something like this. But this will probably change its reference. No, this is not the way that can work for us. We need to update everybody of the existing thing. Oh, that is why. Hmm. Okay, this might be the solution that we need. Okay, so you see, if you don't know what to do, you have to search for it and spend a lot of time. I hope it will work this time. Okay, initial crawling, it is done. Let's see. Okay, here, yes, this one, and let's try update. Okay, this time it is saying that it does not exist in the context. But here it says it does exist. This is so. Maybe I can directly set values instead of current values. Okay, let's just try the add or update then. We can write a copy code, but that is not what I want. Okay, they say that this is not suggested to use, but I am sure it will work. Okay, let's try something like this. Okay, first it will add. And now it will update. Okay, last crawling date is this one, and let's crawl again. Okay. Okay, let's save it somewhere. Yeah, it is not getting updated right now. So the add or update is not working. We have to change its state to, I think, modified after the add or update. Okay, I hope it will work this time. Okay, let's try. What about we edit without checking it exists or not? Let's see what happens. It will work when first time edit, but will it work the second time? Okay, let's open some random page. Okay, it is crowded, and yes, it says that it is already added. Okay, maybe maybe we can make something like this. Then we can edit and go save changes. This should work, but I'm not sure why it is not working. Because they say that it is not synchronous. Okay, this is initial crawling. And then simply I just need to remove this, I think. Yeah. Okay, and try like this. Okay, let's crawl another link. Okay, so let's see. Okay, I did delete it, everything, and try. Okay, it is added, and last crawling date is this one. Let's try update, and okay, it is getting updated. Yes, first it is deleting and then reinserting. Okay. All right, finally we have solved it. So first we remove it, save changes, and then we re-edit in our approach. Instead of this approach, for more performance, you could copy every value of the new parameter, new object to the existing object. I think we can make it. Let's find that method as well. Okay, so this is the way it works, but there is property copy. And yes, property copy is an extension. Okay, so there is another one. Okay, so this will be the another version. This will be using reflection for copy, and I believe it will work as well. So this brings, of course, extra overhead to the server. To avoid that, let me show you what we are going to do. So what I am going to do is, let me show you. If it is not null, we will use copy properties to so this object source to destination. Okay, so the source will be final object and the destination will be vr result. Okay, and then I just need to save changes. Okay, this should work as expected, and this will also not bring any overhead to the server. Okay, method attributes. Okay, I have that using system reflection. Okay, let's start. If objects are null, then it throws an error. How you define it is totally up to you. Okay, initial crawling. Okay. Okay, it is added, I think, like here. Okay, on 18,873 updated, and 18. Okay, it is getting updated as well. So let's see which query is getting executed in the update. I think it should update only the changed values. So it changes the discover date and last crawling date, source and fetch time. Okay, so it is changing discover date, last crawling date, source code and the fetch time ms. Because they are only the changed values and the rest is same. Okay, working perfectly fine, updates only the changed values. So we are using copy properties, which is a generic class extension, and it uses link queue and reflection. So it doesn't copy the private property and null property. Yes. All right. So if we are using private property, we can't copy it. However, all properties are public here to be settable. All right. And so now we have done reflection and changes. We can continue. First, we need to also add extracted links. Okay. And how we are going to do that? Let's see our button click here. So it calls a crawl page. Okay. Our crawl page method call will also add new URLs as uncrawled. Okay. So we need to have a boolean variable here to set them as not crawled, and then we will have another method which will periodically check that we have uncrawled links or not. And I think from last crawling date we can already have that, or from fetch time, or with addition of a boolean value. It is totally fine how you design it. So I will add a new column here, unprocess it, and it will be bool, which is bit, by the way, and it will be 0 by default. Okay, or let's say is crawled. Okay, and let's update the table. Okay, table is updated. Then I have to update our EDMX, which will regenerate our model. Update model from database. I click refresh, finish. Okay, it is added here, and I can see it in here. However, it doesn't have a default value right now, so I will set the default value in my derived class these dot false. Actually, the boolean is by default false. However, let's set it to be sure. By the way, not crawled success, but I think is crawled, but why I cannot see? Oh, I haven't saved it yet. Let's save it first, because it will update the file, the class itself. Okay, updated, so I think it should appear now. Yes. All right, and then after crawling is done, I have to save the new discovered URLs in the database with the default values. Okay. So where we are going to do that, we are going to do it after here, we can write additional methods such as private void save discovered links in database for future crawling. This is a really long name, and it will take a list of per document list discovered links. Okay, and what we are going to do is we will save them in the database if they are not exist in the database. Okay. So it says private void. It has a private static void, by the way. Okay, and basically what we are going to do is simply we will do a for each of discovered links. We are per link, and we will compute hash, but for computing hash, you see I am calling multiple methods, so I think I can add here as a compute hash of our system is string sr url, and it will simply return sr url normalized url and compute hash like this. So whenever so I can make this as private, and I can make this private as well, and then I will make them like this. So I'm reducing the chaining of events. Okay, and okay, nowhere else. And in this for each loop of my new method, I will check whether they exist in the context or not. How am I going to do that? I will use the method I have used it, but right now I am doing some copy pasting, so you should try to find a way to remove or reduce the copy pasted code. So it will check with URL hash, and I will call by the way, here per link discovered links, and oh, I need to for each another thing. Okay, this is not a list, but I will just get the per document, and here I will for each the extracted URLs. Okay, now I can compute hash of our system, and if it is not null, by the way, this will check whether it would get the all values. So instead of this, I need to check it exists or not in the database. A lighter weight checking code I should write, not get the entire record. Okay, so what I need to use is any, not where. Any, so any will return a boolean. Okay, and let's see what kind of query this is executing. You see, when you are developing a system, you should always try to optimize your database queries. Otherwise, you would have lots of performance problem. So we will call this method here, and it will get okay, it will be called here actually. Maybe Okay, let's call it here. Save crawl in the database, of course, if it is success, and then save the document results here. Okay. Okay, let's run again. Okay, for example, let's try this URL. And first it will run and crawl the page, and then it will call this method. Okay, so let's see what kind of queries it will execute. I am expecting it to check whether that ID exists or not. I see. So I have to calculate it here. Like this, because this will return a string, and I have to check it here. Okay, so the B here is the database record. I can give it any name in the link queue, it doesn't matter, and it will check that whether it matches with any hashed link or not of the new discovered URL. Okay. Okay, let's try again. All right, and hashed value here. Okay, result is true. So this link was already in the database, which is this one. Continue. Okay, we are going to check what kind of query it executes. So it executes that select case when exists select one as c1 from main URLs as extent1, where extent1 URL hash equals to p this variable, then cast 1 as bit as cast 0 as bit. So it is checking this hash exists or not. I can also execute this method here to see what kind of index it is using with include actual execution plan, and you see execution plan is index seek. It should be always index seek, not index scan. Okay, because index seek means that it uses the index properly and checks it immediately. Okay, it doesn't scan the entire table. If it is index scan, it is not good. Okay, if it is table scan, it is worst. If it is index scan, it is still not good. If it is index seek, it is the best. So what you need to aim is index seek in your queries. Okay, in your database queries. Constant scan is meaning comparing constant, it is nothing. All right, so our method is working correctly. And then if it doesn't exist in the database, we will compose a new crawling result object, and then we will deserialize it. So to make it, I will add another method here, method extension. Let's call it as, it will return, by the way, main URL type. convert to base main URL class. It will get crowded URL class object. Okay. It will return simply this. I am writing this method extension to prevent code duplication. Why? Because I will be generating an instance of crawling result here. Will be equal to something like this. And I have to set several parameters. So in the per document class, I will also add parent URL. Okay. URL. So where do we use it? Where do we set it actually? Okay. Okay, in the extracted links, we have the parent URL here, as you can see. So we will set the parent URL as well, equal to sr URL. So this is the parent URL of the discovered links. And I will also use the link depth. And so where will I keep the depth of the crawling link? Okay, I think I can keep it in the per document as well. So the link depth will be equal to +1 of the parent URL's link depth. Alternatively, I can provide it to this method as well. However, yes, it is keeping it here is, I think, better. It is not much an overhead. So okay. And I have to modify here. So here I will provide link depth level. Okay. And okay, let's set the new values. So what values do we need to set? The compression percent should be by default 0. So we can set it here. Okay, and what other values? Okay, it is done. Crawl success will be by default. Discover date. So the discover date may also come from per document, or I think what I can do is, yes, I think I will do this. So let me modify this per document. We don't need to keep them here. So I will remove this, and this. I don't even need it. Actually, I don't even need per document. Let me show you what I will do. Okay, let's remove per document at completely and on our extracts crowdlink results. Okay, so it should work right now. So this extract links method will be void and it will get per crowdlink. I mean crowdlink result, and it doesn't even need the HTML document, but we can keep it. Okay, it doesn't need this as well. Okay, so the URL already exists in the crowdlink document, and I don't need to set this. So here we will use the discovered links. Okay, and then we will set it to distinct like here, and we will set the title as page title. Okay, parent URL is already set, link that already set, and it will not return anything. Okay, since this is a class, it will be getting these objects reference, and therefore I don't need to do anything else. And we are providing HTML document, and it is also an object type, therefore it will also pass the reference to the extract links. So basically this will not bring any overhead to our methods, and I don't even need this discovered links, this. Okay, and okay, so in the save discovered links, I will just get crowded result like this, and I will iterate through its discovered links. Okay, nice. Now we can set the values. So is crowded and fetch time ms will be 0 by default. Let's set the default values here. Okay, we have the discover date, compression rates, percent 0. It is already 0 actually. Discover date, fetch time 0. So this is explicit default value setting. And is crowded false. Okay, we set it. Last crowding date will be not date time now, but if date time. Let's set it as 1900. Okay, 1. And what else there is? Link depth level 0 by default, and or 1. Yes, let's make it 1, not 0. I don't know, we should make it 0 or not 1. Yeah, let's make it 0, not 1. Okay, and then page title by default nothing. Did we allow the null? Let's check it here. Page title. Yes, we allowed null, so we can make it null. If you allow null, you have to write your queries according to that. Source code can be null. So the source code will be null. And what else there is? URL cannot be null, so I will set it something like this, and URL hash will be something like this. Okay, I think we have set all the default values. Oh, the discover date, I think we can set it as by default date time now. Fine. Okay, URL discover date link tab parent URL hash. Oh, parent URL hash that is. So there's parent URL hash. I don't keep the parent URL because I can get it from the database with querying it. It would be duplicate value keeping, because when I check the parent URL hash record in the database, I can get the URL of that record. So I don't keep it again. It would be a waste of storage. You can keep it for your purposes, but it is not necessary. So the parent URL hash is not also null. Okay. We did set to null ones and we did set default values for other ones. And then I will only set the URL equal to your perlink and normalize URL. Okay, and are we making it in the other one, in the crawling button? Yeah, let's also normalize URL here. Okay, usually I'm not able to call normalize URL here because it is not public. So I have to make it public. Okay, so let's normalize it. And let's normalize it here as well. And I don't even need to provide discover date now, because now I can set default discover date as this date time now, and I will remove it. Okay. But I am considering that I will fetch the URLs from the database. Therefore, if I provide, my system design would work better. Okay, I will leave it. Okay, and save discovered links in database for future crawling. Here we set the URL, and then we need to set the parent URL hash, which already exists here. Hash it URL hash, and I will set the depth link depth level as the depth level of the +1, like this. And okay, so I have to make it explicitly short. To do that, okay, and what else I need to set? Let's check it out. I set URL discover date link depth level part URL hash last ground date. It will be default. This will be null. This will be 0. This will be null. This will be 0. Okay, this will fall. Okay, now it should work. Then I will add it to the database. Okay, so it will be simply like this. Okay, context tbl main URLs, add entity, and let's see, to adding it I have to convert it to our main base class. Okay, so at the end, after the for each is done, I can call save. Okay, However, this is still not thread safe because if multiple crawling agents call this method, then there would be a synchronization problem between multiple agents because multiple agents can crawl the same page at the same time. Therefore, if they access the database at the same time, it will cause us a desynchronization problem, and we will try to add a link to the database which already exists. Okay, so let's start our application to see whether it is working or not. I will delete all the links in the TBL main URLs. And then select everything from TBL main URLs. Okay, it's empty. Okay, let's crawl our web university website and see what kind of results we are getting. So you see our application is frozen because we are not doing multi-threading. Okay, we have a problem. Okay, it says we are trying to add duplicate. How? How we are adding a duplicate record? I think I know the reason. Because this is not completed. What I mean is, let's select all. Okay, so this hash already added to the database. However, here, when we check it from the database, it's like this. It's returned false. Therefore, the discovered link was tried to add to the database. How can I fix it? Let me show you what I mean. Okay, we are already having some synchronization problem. Okay, so let's put a breakpoint here and see the first URL. Okay, so let's see what is the first URL. Okay, first URL is this one. Oh, I see. We didn't set the hashed URL here. Therefore, it was giving an error. So the hash URL hash will be equal to complete hash of our system. Okay, now it should work. So let's try again. Let's delete it. Okay. So in your project, you should also have application-wide error handling, which we have shown already. To handle such uncaught errors. When you are dealing with external resources such as network, there can be always errors which you failed to cover. Okay, everything executed. Okay, so our main URL has added with link depth 0 here, you see. Then other ones are added to discovered links, and their parent URL will be same, and which will be equal to the hashed URL of this link. Okay, you see. So when I query like this, so the hashed URL of the Toros edutr is equal to this one, and let's select all from TBL main where parent hashed URL equal to this one. So it will bring me all the URLs that are discovered in Toros edutr. Okay. However, we are not removing the ending this, and we should trim it because you see it re-adds to Toros edutr. In some cases it may cause a problem, but it is up to you how you handle the URLs. Okay, URLs ending slash. Okay, this is true. So if we remove the ending trailing slash, we may make the URL not working. Therefore, we can keep it like this. Okay, so we can discover and extract the new URLs. And so the source code is saved with gzip encryption. The fetching time is like this. Compression ratio percent is 25%. Page title here. And is crawled. Yes, we need to set the is crawled true after we crawl. And so here I will set it. And how we are going to set it? We are going to set it like this. Okay, is crawled true. All right, I think it is done. You can also see the queries it is executing here with their duration. And for example, this is non-related or queries. It is a system query. Okay, and let's delete again to see whether this crowd is working or not. All right. Okay, and let's see, is crowded? True. Yes, everything is working fine as expected. We are also gathering the external links here. So you can add a check to prevent external links to be not crowded. It is up to you. We can also save the root domain of the discovered links and crowded URLs. Okay, so last crawling date is also incorrect. So let's add the root URL column. It will be like this, and should we allow it or not? I think we don't I won't allow it, so I have to delete records first to make this change, otherwise it would give error. Okay, root URL, and would I need anything else? No, I think. Okay, and let's update our EDMX. Okay, refresh, finish. Okay, let's save it. Then I will get root domain. Okay. Okay. Okay, let's try this. Maybe this will work. Maybe this is a good one. Let's try this. Okay, let's add it to helper methods. So this will get a URI and it will return the root URL. Let's call it as return root URL. Okay, and I think I will return absolute path as return absolute URI. Okay, all right, and let's see. So this is new URI, and I think this can get string. I will make it as okay. Now it should work. So we will set the root URL and we can set it here. Equals URL dot. I will make this an extension also, so I can call it directly. All right, and I will set it here as well. Okay, so we will be using the root URL too, and with root URL we can make queries based on that. We can compose an unstructured, unclustered index. So root URL can be very useful in our crawling. Okay, let's see other our root URL works or not. Okay. Yes, root URL. Let's check the root URLs whether they are all root URL or not. Okay, so our method is not working as expected because these are not root URLs, obviously. And therefore something is not correct with our code. Yeah, we need to fix our method. Mm. Yeah, maybe we need to get just a host. Okay. So this is what we need, perhaps. Okay, so maybe we need to name this as host URL. So let's update our DMX. And you see this is not removed, so I will remove it. When you make a rename, it doesn't remove it automatically. Let's save it. Okay, and we will change this method as host. And I also need to change some parameter names to host URL here and here. Okay, let's run it again. So okay, interface is still reading. Okay, because we are still not using tasks or threads. Okay, the host URLs are like this. Let's see them. Okay, I think now it is working as we want. Nice. So the hosts are correct. Yes, everything looks correct. Okay, I will take a pause. Okay, and so Now we are going to write a timer, dispatcher timer, to check which links are waiting to be crawled. Okay. So our crawl page is taking an URL and URL depth and parent URL and date time for crawling page of discover date, and so when we save it, we are not changing the values of non-change values. Therefore, okay, it is not very important, but let's make it. So here I will code a dispatcher method to start initialization and then continuously crawling new discovered links. So to do it, C# BPF timer. It is dispatcher timer here. So this is dispatcher timer will check checking timer. Will check which links are waiting to be crawled. So to be able to use it, okay, let's also compose the method. We need to set with which frequency it will start. So I will make it check every 100 milliseconds whether there are new links or not. With 100 milliseconds, we would have 10 concurrent crawling. Okay. However, we could also do it in a different fashion. We can keep track of how many links are being crawled at that time. In your project, I want you to be able to separate concurrent crawling for each different host. Okay, I won't show it for you right now, but I will show you keeping number of concurrent crawling count. So let's define it here. Okay, concurrent is okay, reading like this. Let's make it equal to 20. Okay. And for performance, we will apply this code. Let me open my last year code. Maybe we have shown it in this lecture as well. So let me check them. Okay, let's check 10. Not this one. Not this one. Okay, none of this. So I will check the previous year. I am going to add code to improve performance of the application in strong computers. Okay, here. With this, we will have much higher thread pool at the beginning, and also we will have no concurrent crawling limit. You can look for these on the internet, and also we will change the garbage collector. I think it is inside up config. here it is on the runtime. So let's change this as well. Where do we put it? We put it on the inside runtime, and runtime is set below configuration here. Okay. So I have written an article related to allowing very large objects in the application and also enabling the garbage collector server mode. They significantly increased your application performance with addition to this, and you can look for my article related to it. I will show you. So the article name is Focused Web Crawler Development. You can look for it if you wonder more about this. Okay, and so let's change the name of this and start pulling, awaiting URLs. Okay, and this will check this method each 100 milliseconds, and we have our setting. I will static int. Okay. All right. So the key point here is with every 100 milliseconds querying database and getting URLs waiting to be crawled. Okay. So for synchronization, when you do dispatcher timer, they may tick at different times. I mean, it is not as you expect. They are added to queue of your application, and if your application is not able to process them, they may not tick with the order that you are expecting. So we will need also synchronization. Therefore, I will compose some private locking objects. Object lock, let's say sync equal to new object, and I will lock this object for synchronization inside this method call. So even if my dispatcher starts this method before previous method ends, it will wait this lock object. Okay. All right, and alternatively, we can check if this object is locked. We can just return it from this. Let's say, I don't know how can we check. Let's see. Okay, so there is monitor, try enter, and it returns true. So, but this is not the best way. Okay, I will just do something like this. I will add a private, another value. Equal to false. I will just return, and I will set it here true. Okay. Yeah. It is the same logic that we are applying. Okay. Then we will query database for the evading URLs. How we are going to do that? We will use our, of course, the context here. Okay, so db. For naming, we can use context as well, but you can use db, whatever you want. And from main URLs, we will select which values we are going to select. We will select okay, let's see. I need the URL itself, and I need, let's see, how can we define it? Okay, so it is like this. Let's copy and paste it. So here, where x hash, we will check is crowded equal to false. Okay, you see, we are going to pick URLs with is crowded false. However, how many I need to select? I need to select top 13 of them. So okay, top X. I know how to write them in the SQL, but I don't know how to write them in. Okay, that is take 5. So here we will add take. How many we need to take? Let's take 20. Okay. And you see, we need additional column if crawling fails. We need to keep a counter to not try to crawl it forever. Okay, so let's say try counter equal to small int, and by default it will be 0. I can programmatically set it as well. Okay, you see, it doesn't allow me to modify non-nullable column, therefore I will delete existing URLs. Try counter, or let's say crowd try counter. And this can be tiny int, not small int, because we will try up to 3 times. Okay, and or we can, instead of this, we can set base it on the last crawl date. So it is up to you how to set it, but yeah, let's try with the crowd try counter, and I need to update my EDMX, so I will show you how to set try crowd counter as well. Okay, let's save it. Okay, so let's update our derived class here. 0. And if the crawling fails here, what we are going to do is we still need to update our crawling. Okay. So how we are going to update it? I think we can update it with still entering this one. So before saving extracted links, we will save the crawl date in database, and only if it is success we will do this. So we may need to modify here. So let's remove this. If crawling failed, some values will be null, obviously. So okay, this will be false based on some attributes. Okay. So if crawling is true, success is true, we will make it like this. Okay. So we will set only some values if success is true. Okay, crawled true. And okay, so we still need to set it here. Okay, parent URL true. Parent URL can be still set here, and okay, this will be only valid if it is crawled true. Okay, and we will set crawl try counter 0, and else we will increase it by 1. Okay, but we need initial value as well. So how can we do it? I think we can do it here. Copy properties. Okay, we can do it at the end here. If crawled failed equal to false, we can increase the crawl try counter by 1. Okay, so now it should be work as expected. Okay, and in our checking method we will have several things. We will check them with is crawled false and x dot crawl try counter smaller than maximum try count. Let's say IR 3. So it will try up to maximum 3, so it should be smaller than 3. And what values we need? We need okay, it says anonymous type. Select X div. Okay, so we are going to select, it says table does not exist, x dot. Okay, I need URL. Okay, and what else I need? I can pick it as URL. X dot. I don't know if I need to define this. So let's pick also no, I don't need that. I don't need that. Link depth level. Because I will increase the new font URLs and okay, nothing else. And I need also order by, so I will order them by I will get the first discovered, so I will order them by ascending pr and date discover date. Oh, I see. I have to order them first here probably. Order by okay pr dot discover date. Okay, and select okay top 20. All right, and this will return me some results. So this will return a list of TBL main URLs, I think. Okay, start list. Okay, and I need to convert it to list perhaps. Okay, what is the error? Cannot implicitly convert type system code external list anonymous type string URL to so let's call this as var returned list. So this is equal to list A. Anonymous type A is a new string URL and short link depth level. Okay, then I should be able to do a for each inside returned list per returned, and from per returned, let's see. Okay, I am able to access them. Link depth level and URL. That is what I need. Okay, but we also need another variable to keep track of our started tasks. And so private static list task lst crawling tasks equal to new task list. And then I will start crawling tasks with a timeout. And to do that, let's calculate how many tasks are currently crawling or not. So you see, I am doing everything inside lock. Therefore, everything being processed here will be synchronized. So while we are running task, or let's say, let's make it like this. Where okay pr dot status equal to pr dot exception, or let's say status dot on to completion. Okay, let's see. Okay, I think we can make it like this. Not equal to run to completion and then another where, or we can add or like this, I think. Okay, VR status not equal to task status fault. Okay. To list. So if it is faulted or run to completion, I will remove them. Are there any other one that I should remove? Status not equal to task status dot cancel it, faulted, run to completion. Okay, I won't use. Okay, faulted run. Okay, so these two are enough. So here, basically, I will remove the tasks that are already completed. Then I will calculate how many tasks I should start as a new task, because I want to keep only certain number of tasks to be crawling. Okay, so here let's say, let's calculate how many tasks I will start. Task count to start equal to concurrent crawling minus crawling tasks count here, and if task count bigger than 0, task start count, I will take it like this. Okay, you see, I will get that many URLs from the database. Then I will start a crawling task for each of them. Task and okay. Okay, I can do that. This. While we are started, task equal to task the factory start new. Okay, I will start a task like this here, and here I will call crawl page method, and URL crawl will be varpar returned URL depth will be varpar returned link depth level, and parent URL will be, okay, I need to pick the parent URL as well, so let's get it as well. Oh, I can't get the parent URL here. Okay, so I will be providing it as parent URL as null, and discover date will be as null because I already have them. Okay, it says we can't have default. Are there defaults? Okay, there is mean value. Okay, I can use it. And it will start this. Okay, I also need to define a timeout. Okay. How can we start timeout? How can we start task timeout? I don't think we need to define timeout here, because the timeout will be already in here. This has a timeout, and okay, this has some default timeout. I think maybe we can change it here. Let's see, timeout. Yes, there is timeout, as you can see. You can set the timeout as 60 seconds. Okay. Or you can leave the default timeout. Okay, it is new time span. Let's make it, for example, how many seconds timeout? I think we can make it 2 minutes. Okay, so 0 hours, 2 minutes, 0 seconds. Okay. So this is the default timeout and okay, you can also add here continue with and or continue on error, whatever you want. But I won't be doing it. So if any error happens inside it, it will just only cause a problem inside this. However, the new ticks will continue doing. But there is one issue with that because we are being processed here, so I have to set it free as false here, and I don't know, we have to run the application to see whether an error occurs or not. Okay, all right, and this should let our application to run smoothly. Okay, I also need to add this started task to my task list here. Add, we are started task. Okay, now the application should start crawling indefinitely. And we didn't start the checking timer. I will start it as well. However, there are still some issues, such as if an URL is being crawled, we should not start another crawling. So therefore, we will have another object. I think, where can we set it? I think we can make it with continue with yes. So I can remove after it continues. Okay, so let's make it like this: private static list setting st currently crawling URLs. Okay, it will be empty at the beginning, and with continue with, so continuing action will be something like this probably. And okay, I will get a value from returning value, and I will remove. However, when I define continue with, it won't be locked. Okay, so what I need is I need to have a lock object here, and I need to lock this currently crawling URLs object itself, and then I will remove this URL dot, oh, this is the status. Okay, can I use this parameter with continue with? This is a local variable, but will this local variable change it? We can put a breakpoint here to see. I don't know if this would be remaining same or not. Let's think about that. Okay. And before we start the task, we also will check if this URL is being crawled. We will not crawl it. Okay, if this list containing the URL here, we will just continue. URL, we will just continue. Okay, so this continue, this for each, and we will have synchronization with lock. Okay, now we can, I think, test. Let's make a small test, and we will have some visualization and see what's going on. Okay, one moment, my little girl is here. Okay, my children. Okay, let's delete the records from the database first. Okay, let me delete them. Okay, deleted, nothing there. So let's start crawling. Okay, one moment, let me start the crawling. Okay, let's see if there will be any error or not. Did we start this polling thread? Oh, we didn't start it yet. Okay, let's modify and add to start. All right, let's start. Let's delete the crowded URLs. Okay. There can be still errors, but with debugging, we should be able to solve all of them, all of the problems. Designing a web crawler is not an easy task. The application can be very complex. Okay, so what is the error? Okay, we got a null URL. So where could we? Okay, I know the reason. Okay, here. We are starting task, but this for each would return faster than this task to starting. Therefore, there is a data race, and so to prevent it, I need to define a local variable URL to crawl equal to URL. Okay, link depth. Okay, I am so having a local variable of for each variable because this task starts whenever it is available. However, this for each continues, and so we will be replacing this with this, and this, and the depth will be here. Also, we are providing null and min value here. So let's fix them as well. So if the parent URL is null, I won't be setting it. String is null or empty. Parent URL and discover date if discover date is not equal to date time min value. Okay. All right, let's restart and let's delete all the existing URLs and let's see. Okay, once we make the application running, we will improve it. Okay, now the timer has started. Okay, we have another error. Validation failed for one or more entities. See entity validation error. So what is the error? Let's see. So we have made some save discovered link. Okay, one moment. Okay, so we got an error here, and let's check what could be the problem. Oh, you remember I said that we had to have some synchronization in this method because multiple crawling tasks will call this method. Therefore, to have a synchronization, we are going to have an object of private lock, object to use as a private lock. Okay, something like this, and I will use this lock for this DB context. Okay, I think it looks good. Okay, even if multiple methods now call this method, multiple tasks call this method, we should not have any problem. Okay. Okay, it is empty now. Let's start. All right, let's see. Okay, we got another error. No, this is weird. Why? Okay, the application continues, but there were an error. Hmm. Maybe we should save it. You see there are multiple crowded URLs, but it doesn't increase anymore. Okay. Why there were an error of context validation? Let's run it again and try to find the cause of error. This time I didn't reset the database because it should be able to continue wherever from left. This is interesting. Why we are having an error? Okay, no error so far. You see the number of URLs is increasing. It is crawling. But the error happened here was bothersome. Okay, so it is released now. Okay, currently application is stuck somewhere, and let's check where our logic fails. So let's check here. Okay, being processed false. Okay, so let's go to here. Okay, so how many crawling tasks? We have 20 crawling tasks, and they are run to completion. Oh, but our where clause is not working. Why? They are run to completion, and we are selecting where status not equal run to completion or status not equal false. I see. I have to use and not this one. Okay, let's remove breakpoints and run again to see. But that database save context error was bothersome, so we have to solve that as well. I don't know what was the cause. If it happens again, we can debug further. Okay, how many URLs we have? We have over 800 URLs now. You can also have some logging methods to see which crawling task started, when it is started, when it is ended. With stream riders, I will also show you them. We can also see them here. Okay, last crawling date is not getting updated. This is wrong. And link depth level is also wrong. And we have an error here. Entity validation errors property here. So what is the error? Original values cannot be used for entities in the edit state. What does this mean? Let's see what does this mean. Okay, we could be having problem Okay, let's make changes here to discover what is causing a problem. Okay, so after each insertion, I will update the database instead of updating at once. So we will have an idea of what is causing error, which value is being problematic. Also, currently our last crawling date and link depth level is not working correctly. Okay, so now we can see the error. Interesting, it looks correct. Everything is there. It is YouTube URL, last crawling date is there. True, host URL, fetch time, discover date, compression pursuit. But still we have an error. What error we have? Oh, what is the error? Okay, the field URL must be string or array type with maximum length of 200. I see. So let's see what is the URL. Okay. You see, we didn't decode URL, therefore we get over 200. Let's say we need to decode discovered URLs. Okay, this is really weird. And this is actually multiple URLs. Also, we need to ignore bigger URLs than 200 characters. Okay, so let's get to our discovered links. Okay. So where do we get the discovered links here? And it appears that we are not HTML decoding. Okay, decode. So let's write a method extension for HTML decode. URL. Okay, so okay, it is here, I think. Entities, what does this do? Oh. Okay, let's try this way. I think it should work. And we will decode URL here. Okay. And then we will check its length here. You see we are making a distinct and where okay smaller than 200. This is our maximum database length, therefore I will use this. Okay, and are there anything else? Probably not. All right, so we can restart. Oh, we were having another error. I think it is about with link depth and last crawling date. I see that last crawling date never changes, so let's see why. When we crawl a URL, we have to set last crawling date here. Okay, so saving database. Okay, and I think we need to set it here. Or we can even set it here. Yeah, it is fine to set it here. So yeah, I will set it here. Last crawling date equal to date time now. And we have a problem with link depth. Okay, URL depth. So where could we having that problem? Okay, let's delete it and restart to see whether we get any other error or not. We are still saving changes after each add, and that is not a very appropriate way. It is slower. Okay, we will start seeing queries here. Okay, you see so many queries are being executed. You see number of rows, the query count, and of course my computer is now having problems. Let's see. Okay, 400 links. Okay, there is still an error with link depth. I see. When the page gets crawled, it updates link depth to 0, which we need to fix it. And fetch time is here. Okay, everything looks correct. And let's see the URLs if there is any encoded URL. Okay. So basically we are crawling whatever we can get. Okay, how many URLs so far? 700. Okay, what we need to fix it when the URL is getting crawled, it is set to 0 in the link depth. Can we verify that? Yes. Okay, let's fix that as well, and let's get back to context changes to here. Okay, so when we are updating a URL as Crowdlet, the link depth is changing. Why? I know why. Because you see, we are overriding everything of our changed values, and therefore it is modifying everything. And to fix it, first we need to either change manually or provide all values of crawl. I think I will provide all values. Yeah, I have to provide URL depth. Or keep them here. Okay, let's keep them here. So before copying the VR result, let's set which values we want to keep. We want to keep discover date same as VR result discover date. Okay, and we want to keep link depth level same as link depth level, and okay, nothing else. We will copy other values. Right. And are there anything else that we want to keep? No. Okay, so now we can start adding some logging, like started the crawling this URL, or let's add some Streamwriter. Okay, so you will have idea of how to have a logging system. Okay, public static void log message. Okay, and this will get a message, and to log I will use the system writer. And it will be such as docs.txt, and it will encoding will be equal to UTF-8, and we will append true, append true. Okay, now it should work. Says you can't define it here. Okay, path and append true, and encoding. Okay, it is like this. So whenever I write something to this, by the way, I will set this to we have a constructor? No. Oh, we have. So there is error logs, and I will also have log auto flush true inside the constructor. And before I write something to log message, I will use a locking object for synchronization. Logs se logs. Okay, and here we will just write the log as write line. Okay, let's write the date of the error, and let's add some top, and let's write the message. Okay. All right. So we can set something like this. Okay. CS helper methods log. I think we had edited as a static. Okay, log message polling awaiting URLs and processing equal to being processing, and okay, let's make it something like this. Top processing result and top. Okay, and number of crawling tasks. And count. Okay. And let's add some more message as well. So let's add a message here. Continue, or let's say crawling, and let's use a tab at the URL. Okay, and removing URL from list. Completed. Okay, and what else? Okay, and starting crawling URL and here. Okay, so let's see what kind of result we will get from these logs. Okay, I did reset, and the logs will be composed in our debug folder. Okay, I will close this to get some, and let's reset this. Okay, let's see how much database where we are having. Okay, all right. Okay, logs file here. Okay, so polling awaiting URLs, processing false, number of crawling tasks 0, and polling again, and now crawling task 20. Okay, always we have 20. And start crawling URL, this one. Start removing URL from the list since completed, and let's refresh it. Okay, for example, removing URL from the list since task completed. And are there any bypass, for example? No. And this is good. Okay, everything is looking nice. And let's see how many URLs already. Okay, 600. And okay, we still have problem with link depth. Okay, we have to fix it. I will leave it to you so you can fix it, and let's see if the last crawling date correct. Yes. So you see now last crawling date is getting updated. However, we have problem with the page title. It is not updated. And you should also fix that. I will leave it to you. I am sure you can fix them and see how many. Okay, 800 now, right now. All right, nice. Source code is getting saved. Also, we should see that first discovered link should be crawled first because we are ordering by date time. So you can log somewhere else the discovered links. Okay, I see this link is being crawled multiple times. A lot of times actually. Why do you think that? We have definitely an error somewhere because this is not how it should be. Because it is starting to crawl same URL again, and again. So we definitely have a data racing problem somewhere. Okay, where could we have a problem with data racing? So is crawled. We have a problem with data racing. I think we can set a wait until task starts. This is not the quest. Okay, we have a problem somewhere. Okay, I think I will write something here. Okay, so log message and string dot join, and let's see returned URLs. Okay, select pr dot URL and let's merge them with something like this. Okay, so let's see the returned URLs. Are they correct or not? I will remove the log file. Okay. Let's start crawling. Let's see the logs. So we have a data racing problem somewhere, but let's try to figure out where it is. Okay, so the returned URLs are different, yes. However, we are starting to crawl same links again and again, I think. Oh, what is the error? Let's see. This time we know where to look error. Okay, an error containing entry, see inner exception for details. Inner exception, okay, it says that violation error message. But this shouldn't be the case. Why? Because we are checking whether that record exists or not. Hmm. Oh, we still have some synchronization problem. I think it is about context save changes. Interesting. Instructor non-public members. This shouldn't be the case. Why? Why it is happening? We are checking the hashed value here. And we are checking the result. And if only the result is false, we are adding it. So why this error happening? And I think I have an idea. Okay, we are here having a synchronization, but we also save database here. Therefore, we are not fully having a synchronization. So to fix that, I will also use a lock here. So let's rename it. And lock database at, and I rename it, it will tell me to rename it. And I will use the same lock here. Okay. So it will be more synchronized between multiple threads. All right, and we were having another problem with the starting the crawl. Okay, so okay, for example, this URL has been started multiple times. Why? Let's see the returned URL somewhere. Okay, it returns, then removes URLs. Running tasks still 20. Then it gets some new URLs to crawl. Then it starts them. And then we have returns, then remove URL. And it starts again. Okay. So let's see our starting process somewhere around here. Okay. Are there any bypass? No. And when starting crawling URL, it starts same. However, you see, we have returned 1, 2, 3, 1, 2, 3, 4 different links, and it started one here, another one here, another one here, and another one here. Okay, all these 4 are correct. Then it did another polling, and it has removed this one, did another polling, and what is this? And did start another crawling, remove this, and what is this again? And started crawling again. This is so weird. So where we might have a problem? Where is this link is? I see. Actually, it is getting one link from the database, and this link is probably failing over and over. So it is not also getting retry count updated here, I think. Therefore, we are getting same link and trying same link again and again. So let's see, where do we have retry count? Let's open our failure function here. And if it is failed, we are supposed to update failure. Okay, so let's run the application. And actually, we will set it here. Let's look for the error logs. Oh, it is empty. So this is not key case. So we have error of maybe crowded success. Still says we have a violation key problem. So what is this value? Okay, there is no such value in the database. This is weird. Oh, I see, I see. So we are checking database. However, in the discovered links, obviously there are same URL, even though we do a distinction check. And what could it be? So there are two URLs which generate same hash code after we normalize them, because you see, when we normalize the URL we convert them to lowercase. However, we are not doing it here, and therefore I need to keep track of added URLs. I think I can keep it here with hash set string hash processed URLs. So this will be a local link, and it is false. Here we will do it. We will add the URL itself. Okay. Hashed link, and if we will enter here only and if contains hashed link false. Actually, we can make this check here. If it contains, we can just continue. Okay, this will prevent the error, but still we have problem of starting to crawl same URL, because let's see, we have problem where depth of the link is still incorrect. And why? So where do we set the depth? We set the depth here, and we don't update it again. So the depth is getting 0 once we make update. And let's find why. Yeah, because we have used the same variable both day. Okay, now it should everything should work. And let's see. Okay, and let's start the application. I am sure this time it will work perfectly fine. Let's delete the logs. Okay, and but did we fix the database querying problem? It was getting the same link. Okay, is crowded. Is crowded was not being updated in some cases. Okay, after task is completed, it has started crawling same task. Oh no, not same. Yeah, this is a different one. Okay. However, I see the same thing getting crawled again and again. Okay, it returns it and it starts crawling without processing. Yeah, I know the reason. Okay. Because we are not adding. Okay, you see the error. We have to add it here if it is not containing. So the list was being empty. All right, and let's delete. Now it will be much faster. In your project, you can calculate your per crawl, crawling rate, speed, crawling speed per minute, and you should also display what is being done at that moment. So there are many things that you can achieve. Basically, you can improve the software a lot with adding statistics and a better display. However, it takes time. It is not easy to complete it within few hours. But at the home, you have much more time. Okay, so you see now we are seeing the bypass because they are already being crawled, and now we can't even keep the concurrent task count 20. And to fix that, we can increase the number of URLs that is being uh, check it from the database, like not only 20, but we can check for 40, 50, whatever. Okay, now it is much faster. Let's see. Okay, already 2000, you see. Now it is perfectly working fine. We don't try to crawl same thing again and again. The page title is still not being updated. I think you can solve it easily. However, we have huge speed. And one final thing that I will show you is using what was its name? Let me see. Observable collection. Okay, I have remembered it. I have shown it in the introduction to programming. Okay, here. Okay, this is the list box that we are going to use. Okay, let's set this list box to this one. Okay, the results list box. Let's make it like this. Okay, and we are going to have an observable collection. Let's define it as well. I will take the code from here. And observable collection is here. Okay. And with this observable collection, we will be able to add elements to this list and update the user interface. Okay, and we bind it to our list box as here. You see, I am binding this user logs observable collection to the list box results as an item source. And whenever I modify this collection, now it will be displayed on the screen. So let's add some results to our collection, such as log observable collection, and insert, for example, this as 0, and I think I need to add date type as well. Okay, and instead of task start count, I will get 3 count of it, or let's say 5 times of it, and then we can break the for each once we have once we exit the maximum number of concurrent correction break. Okay, and we are getting actually not 5 times but only 2 times. Yes, it should be sufficient. And then let's add some more user logs, such as starting to crawl here, this message. Here, and then okay, we can also display other values, such as we can calculate how many crawling we are done with IR crawled URL count equal to 0 and prime string int. And let's keep them inside our helper method, and I will make them public, by the way. So let's define public static int crowded URL count, public static int our discovered URL count equal to 0, and I will show you how to synchronically increment them or decrement them. Okay, so with the discovered links, I think I will only increase it here. So it was, what was it? I can't remember it. Let's see. Okay, interlocked increment. Okay. Interlocked. Okay, I think we need to add threading. Okay. Increment. So this is a thread safe increment, and we will use discovered link count here, and then we will increment the crawling. Let's see, where was it? Okay, here and IR crowded URL count, and then we will update them in the our listbox log. Let's also add a date time. Okay, I think it is here. We can set it here. DT now or DT. Okay, start date. I will set it. Date time now here, and with this I will calculate how much time has passed, and I will calculate the let's say how much speed we have per minute. So we can calculate it as string per min crawling speed equal to date time now minus dt start date and total minutes. Okay, so we will divide number of crowded, it is in here, crowded URL count to double, and then we will format it with to string. Okay, here to string with and to precision per min crawling speed and per min discovered link speed. Okay, this will be IR discovered URL count, and then how much time has passed. Okay, passed time, and it will be like this. Okay. So let's insert that as well, such as here. Time, total time. Okay, passed time, minutes, and crawling speed per minute. And here, and then I think we can add a top character between them. And discover it. Speed. Okay. We can also add total crowded link. String with and 2 and 0 and total discovered link. Okay, this is about visual formatting, not important, but I just want to show you how to use them. I am expecting a much better software from you because you should be able to do it right now. So let's delete everything from our table. Okay, and let's delete logs. Okay, and you should be also able to restrict crawling other hosts, I mean, such as other websites. So when I start crawling Toros Edutere, it should not start crawling YouTube. Okay. Okay, it is getting updated as you can see, but it is too fast right now. Okay, because it is getting updated. Okay, we have a problem with total minutes. Let's fix it. Okay, where is the problem? Okay, it is 0 for a while, therefore not test. Okay, we have to set it here. And I will change this to every second so it won't be that much fast. And okay, let's delete logs, clear database. Okay, let's restart the application. So now our application will do polling every second instead of every 100 milliseconds. So that we can read it. It is still freezing at the beginning because we didn't make it as a task based. Okay, now everything is fine. So our discovered URL speed is over 2000. Our crawling speed is over 100 per minute and it is increasing. And even right now I am running in debug mode, so it is even slower. And however, it may get slower as we are as our number of units in the database increasing. You see how many queries it is running already, 400k, and our crawling per minute speed is like this. However, it is getting decreased. Of course, it also depends on which host we are crawling, and our discovered URL speed is over 5k. And when I query the database, you see it is super fast even in my computer. And let me do some more tuning to see, and even improved speed. So in the database, I will add a index to base it on my query. So it doesn't allow me to define a new index. Let me restart the SQL server. Okay, let's delete this. So in our query, what do we use as predicate? Okay, what I mean is when you do a query, the where clause should have index. Okay, and so let's open the application. And indexes will not be affected, will not affect our program because we are doing from database to code, not code from database. And here I will define a new index, non-clustered index. Okay, so where do we have select? We select based on Crawled, and we sort by discover date, and we also check maximum try count. Therefore, I will add an index with first Crawled here, and then I will add retry count here, and I will add discover date. So this will be an unclustered index, and which other values I am selecting, I will add them as an included column. So it will only use this index to execute this select query. I am selecting URL. Let's add the URL to the index. And I am selecting link depth level. Let's add it to the link depth level. Okay. So indexed key columns will be like this. And you see discover date is sorted by ascending, and we are also doing ascending here. Others does not affect. Actually, we can make this as descending because we are checking that try count is smaller than maximum try count. Okay, and okay, included columns are like this. Let's give it a name. Select query tuning index. Okay. So now our queries should use that index without doing entire table scan. Okay, and let's reset database and to see our final obtained speed. Main URLs. Okay, and let's delete logs file. Okay, let's reboot the application. And let's start without debugging. After the reboot. Okay, start without debugging. When you are not in a debugging mode, it becomes faster. Okay, after the initial crawling starting. Okay, now watch it. Let's see how much CPU. Okay, we are not fully utilizing our CPU, so we can increase our number of crawling tasks. And let's see our network. It is also not being full. So our crawling speed is over 250 per minute. And our discovered URL speed is much higher. You see, it is around 13K. And let's see how many tasks our program is using. Okay, you see SQL Server is also using some CPU. Okay, and our crawling per minute decreases as based on the since we are trying to crawl Facebook, probably Facebook may block our software in a moment, in any moment, I don't know. And you see our crawling task count is close to 20, but not exactly as 20. And total crawled link count is over 300 right now. Okay, and you see we started with Taurus Edutier, but it is crawling everything whatever it finds because we didn't make host-based crawling. I will leave it to you to do. I think you can do it because I have shown you everything that you need for this project. Okay, it is everything. Just you need to spend time, try to understand it, code it yourself. All right. Okay. So I will also create script of this database and therefore you can also execute it. So save it to a file and I save it to our project folder here. Okay, I will call it as web crawler database. Okay. Okay, next. Based on your SQL server, you may get an error and you can just look it and fix it. It should work fine. So here the SQL file, it is something like this. So it uses my folders and you may need to fix them. Okay. And you can also watch the video and compose the database yourself. It is simple. All right, let's see the final speed. So we are now crawling Yolk and we are crawling whatever we find. And so our speed is now over 400, you see. So it depends on the which website we are crawling. Also it is trying to download zip file, which you should prevent, or PDF file. So you will make a list of extensions that you will prevent your application from crawling, such as docx or zip or PDF. And you see the application tries to crawl them, but I think they are failing. Where crawl retry count bigger than 2. Okay, there is no here. Okay, let's check logs for error. Okay, I see the errors. So our retry count looks like not working. Okay, these are the web crawling errors. So you see it keeps trying again and again because our retry count is not working. It is not getting increased. Therefore, we need to fix it as well. And where we do make it. Okay, interesting. Okay. So after we catch the exception, what do we do? We go here, and in here, if it is failed, we increase the CrowdTry counter. So let's run the application to see what happens when it goes to here, why it is not being saved. Hmm. Okay. Crow zip and so what is the URL? Let's see the URL. Okay, this is the URL hash, and after I make change and it is, yeah, it does exist. Why it doesn't save it? Yeah, it doesn't save it. Okay. Wow. You see, source code is null because it is a PDF file. Therefore, we are getting an error here and it causes our application to crash. So it is never saved. And when we are running it in non-debug mode, uh, it doesn't cause our application to crash because this is a task, and when an error happens in a task, um, it is it doesn't cause application to crash when an error happens in a task. If we were doing global error handling, we would see this error. I have shown you how to do it in the previous lectures. However, this CrowdTry counter is not getting updated. Yeah, I know the reason. Because I have to also copy it here. Okay, let's rebuild. And I also need to check source code as something like this, so it will prevent errors. Okay. So let's reboot. Let's run the application. Okay, let's see the failed URLs now. Interesting, very interesting. Zero, and what is the URL? Okay, it says it has updated one row, but why it is not getting updated in the database? Okay, okay, original source code length is 8 characters. Okay, and compressed. Hmm. I think I need to check it like this, is null or empty. And this, okay, and here I will make a check what kind of update it is making. Okay. And I will start SQL profiler to see the query it is executing. Okay, now it has failed, and let's run tuning, and let's execute to save changes here. Okay, so it has updated last crawling date and fetch time, but it didn't update the retry count. Okay, so fetch time updated is 128. Is it true? Yes, it is true. Okay, okay. It doesn't see as this value is changed. Why? Why? It updates. It updates discover date or what? It updates fetch time and last crawling date. And we set them where okay, I think we have a problem here. It gets the destination. Yeah, we are copying the number here, and yeah, we need to set it here exactly. That is why. Okay, you see it is already being too late, therefore I am getting slower. But this time it will work, I'm sure of it. Sometimes you have to spend time, or many times you have to spend time to figure out what is the error. Now we will see the retry count, and we have solved our Latest problem, of course, the application still needs a lot of improvements for user interface and for other options, but I am sure now it will work. Yes, now we can see the retry count failed ones, and we will see them increasing. Okay, so but it will be always as one in this case, because what I need to do is simply this. And then increase by one. Okay, what is this? Now we will see fail it multiple times URLs. Okay, now we will see the retry count. Okay, you see 2 to 1. We will see them up to 3, and then they won't be tried again. Okay, 3, and now they won't be retried again. Okay, they will remain as that. All right, this is it. This will increase our crawling speed as well and other things. Okay, all right, you see it is increasing, but these are remaining same. I think this is enough for this week, and let me upload project file, and I will write the content of this lesson later. If you have any questions, please ask me from Discord. This was the last lecture of this course for this semester. So hopefully see you next semester with another course. And you know, our final project file is stored on our GitHub repository. And let me show you that in a moment. Okay, here you open our GitHub repository. It is updated a moment ago, and you see our midterm and final project PDF here. If you can't see the PDF, just click download button. It will download into your phone or wherever you want, and then you can open it and see the PDF file. Okay, and try to code as good as a software. I mean that try to make your project like your employer has ordered you to do so. Okay, like you will get a paid for it, so it will be better. Okay, end of lecture. It has been over 4 hours. Hopefully see you later.